Hi, I'm Metta Spencer, and we're not going very far today. We're going to the University of Toronto campus, which is my campus, and it's going to be a fun day because I'm going to have a conversation with Ted Kessick. Ted Kessick is an engineer. He's teaching in building sciences, and that's his thing. And he knows how to make good buildings that stand up and don't fall, and even keep you warm or cool as you prefer. And he is actually working in the architecture department, which makes a certain amount of sense. We have just begun to get acquainted, and he told me something fun. I want you to tell my audience because I like to brag about this. Hi, Ted. How are you?
I'm great, thanks. Yes, I was just telling Meta that, when I took my first sociology course, I used her textbook. And so that was my introduction to sociology. We used to have to take a non-technical elective when I was an engineering student. And I was told that a good way to meet all the hot chicks was to take a sociology course. So that's what I did. And it worked out rather well, I'd say.
Uh-huh. Did you meet any hot chicks?
Well, let's say there was a lot that I would have liked to have met.
Well, that's really fun to know. I love it when I come across somebody who once studied from my textbook. About a few years ago, I was stopped by a cop, very rightfully stopped because I'd gone through a stop sign or something, and he was about to give me a ticket. So he wanted my name, and he went off to his car for a long time. He came back and he said, "Your name's familiar. Did you write a sociology textbook?" And I said, "Yes." I'm not going to give you a ticket. And he tore it up. So next time I want a building designed, I'll come to you for advice because I'm sure you will be good to me. So good morning or afternoon. I want to talk to you about mass timber. But
Right.
first, we have to tell people what mass timber is. And before we do that, let's round up a little bit more about your whole bag, which is more than just mass timber. I happen to have watched two little videos that you have posted someplace, and it seems that you also are talking about resilience in buildings. So why don't we start off talking about the whole notion of trying to produce more resilient buildings and and buildings that meet our concerns about global warming, because I think that's the place where we all ought to be paying some attention.
Sure. Well, the place where we are today is probably, I would like to call it a tipping point because we have to make certain decisions, obviously, about the built environment, because what's happening is that we are slowly getting people out of the countryside and into cities. In fact, urbanization is a growing trend. And with that comes the requirement for things like housing and all of the different buildings that support activities, whether it's shopping or schools or healthcare. And so that means that we're going to see a lot of buildings being built. In Canada, just to give it, a proper perspective, we were before the pandemic bringing in well over 300,000 immigrants a year. A place like Toronto, the Greater Toronto Area, was expanding at well over 100,000 people a year, and that's a small size city every year, and so you have to build a lot of stuff, and all that stuff requires energy. First of all, that goes into extracting the materials that are going to be used for the building. And then when the building is up and operating, it consumes energy as well. And associated with energy is carbon. And the problem with carbon, when it comes to carbon emissions, is that it carries with it a global warming potential that's not very good. So you put all of that together, and the question then becomes, well, if we expect this is going to go on in Canada for some time, and I think we will be always a very popular country to come to, so we're going to have a lot of immigration. We're going to need a lot of new buildings, and we're going to, at the same time, try to have a low carbon economy that's sustainable. Somehow we've got to put all of that together. And in the face of climate change, accept that we're also going to be having extreme weather events that are going to challenge buildings. And so we're going to have extended power outages, maybe flooding, in some parts of the country, wildfires. How do we design buildings that can withstand these? So that's the adaptation part. So part of it is mitigation. We have to do mitigation to prevent an increase in carbon dioxide levels in the atmosphere. But then we also have to do adaptation to the realities of the fact that we're probably not going to hit the targets as soon as we'd like. And that means we probably will have more climate change.
What I'm wondering is, how does U.S. infrastructure compare to Canadian infrastructure? Are we in any better shape?
We are in the sense that we did a lot of our infrastructure expansion later than they did in the U.S. So we as a country grew, let's say, astronomically following the Second World War, whereas the U.S. probably started at the beginning of the 20th century. So their infrastructure tends to be a little older when we talk about sewer and water and bridges and things like that. But we didn't build ours any better. So ours is like it's everything else. It's like a ticking time bomb in the sense that it's going to get old. We're going to have to figure out what we're going to do with it. And so we're even rethinking things like how we're treating stormwater and whether we should be coming up with more what we call landscape as infrastructure type solutions, where we get the landscape to absorb the stormwater and deal with it instead of putting pipes in the ground, because those pipes eventually crumble and have to be replaced. It's very disruptive, it's costly, and avoidable. So you're looking at even different. Are you
saying that a lot of the sewage system consists of just draining water out, so and not actually the effluent from houses?
That's right. We have quite a storm water system within a city like Toronto. We also have a sewage system, and the sewage system comes along with also a potable water system. You have to get water into people's houses, and then that water ends up being sent down sinks, flushed down toilets. So, but that's all part of the sanitary system, and so we have these two systems, and the stormwater system would be nice to get rid of as much as we can, just because it's a lot easier to do. The sanitary system is a little more difficult to deal with. Of course, we can conserve water, and we have to, just because we're going to be taking on more population. So, do we want to build more water plants? I mean, it's a big question. Or do we just want to use less water and stretch that water out over a growing population base, which we are the number one consumer of water in the world as Canadians. We're so grossly higher than, let's say, most people in Europe, and yet, you wouldn't look at people in Europe and say, well, they don't shower often enough. They do. They just use different plumbing fixtures that don't use as much water. We equate quality of life with lavish amounts of water that are splashed all over the place and don't do very much.
I've heard that Canada has more water than almost every other country too. So we can be, wasteful without too much hardship at the moment, right?
That's true. But at the same time, you like to think that some of the money that we have going into, let's say, rehabilitating the municipal water systems in places like Toronto and other cities, that maybe a little bit of that could be devoted to giving some fresh drinking water to people on the different Indigenous communities across Canada that have had, in some cases, boil water advisories in place for over 2 decades. So, if we really want to talk about all of these issues, and they all come down to this whole business of, equity and diversity and inclusion and transparency. These are these huge sort of things that we hold out to be, very important values. You'll see how they get reflected, especially when it comes to things like infrastructure and buildings and the built environment, because they aren't very evenly distributed in terms of good opportunities, which is the reason I was attracted to this field. I realized that, Winston Churchill was right when he said that we shape our buildings, thereafter they shape us. It's so true. Like how we live, where we live, the quality of community life, it determines everything from mental and physical health, whether it's a walkable community or whether we commute, in which case we're not getting as much exercise. And of course, we're polluting the air with automobile exhaust. And so all of these things are connected. And so, it's a fun, for me, it is a fun thing, because I always think, well, I think I can make a difference by educating people about maybe the better way of doing things. And we do come from a past that was quite wasteful because it was encouraged in the name of progress. So progress is an interesting concept, which really is an invention of sort of European culture. It doesn't exist in most cultures. Most of them have a sort of what we would call a circular economy model. And we have this linear progress thing where things get bigger and better and all this kind of stuff. And of course, what it's done is it's really killed our environment. So we've got to sort of change our thinking. And so one of the fun things I like to do is to, in fact, learn from the indigenous models of what they did and how they did it. Mm-hmm. And what they did is they worked with local materials. Obviously, there was no Home Depots. When Jacques Cartier came to Canada, he did not find Home Depot stores serving the needs of indigenous people. They were putting buildings together with sticks and bark and all kinds of stuff that was local. It had zero carbon footprint. It was all biodegradable. There was no pollution associated with it. It was completely sustainable. And somehow we felt we were going to improve on that. And it looks like we didn't.
Mm. Tell me about whether or not urban forestry would help this problem that you mentioned about runoff of water. I'm on to one of my big enthusiasms is trying to promote more trees in cities. Would that help absorb the water instead of having it run off?
Absolutely. These are the things that we should be seriously considering. What should we be doing? We have in Ontario a lot of what we'd call fallow farmland that used to serve a purpose a while back. I'm talking now over a century ago, and then it's not really ideal for certain types of agriculture, but it's perfectly good for trees. And so some of the Scandinavian countries have taken up that sort of idea quite seriously and have sort of started to aggressively plant trees. I mean, it is treating trees almost like a crop, but they found that it had a lot of benefits. And one of the benefits, of course, is controlling runoff and erosion, but it also cleans up the air because, trees, besides producing a lot of oxygen, also plaque out a lot of pollutants. I mean, they have a huge surface area in the leaves and stuff sticks to the leaves. And so you'll notice always that air quality in leafy neighborhoods, as we like to call them in Toronto, is much higher than it is in places where it's just asphalt and the dust keeps blowing around. The first thing to understand is that buildings are completely what we would refer to as prosthetic devices that are an absolute reflection of the human physiology. So whenever you're making a shelter environment for a species, if you're making it for a whale, it's going to be different than if you're making it for a butterfly. And it's very different if you're going to be making it for a human. But everything that we do, you will find in buildings that there is a one-to-one prosthetic correspondence. So we have a digestive system. Of course, we have a plumbing system to deal with that. And we need to drink water, so we have a potable water supply. And we need energy, and so we have that. We need access to air, and that happens. We need to be able to regulate our body temperature, and that happens. Buildings have a skin on them. And so do humans. So buildings are always like the third skin. The first one being the one we're born with, the second being the one we wear when we put our clothes on every day, and the third one being the shelters that we find ourselves in. We're very fragile creatures, very narrow temperature tolerance within our deep core body temperature of only a few degrees Celsius. Get too cold, hypothermia, get too hot, you end up with heat stress. So maybe very few parts of the world where we could live without buildings. They're far and few between. We always will need buildings, and buildings are prosthetic devices. They consist of two types of systems. We have a passive system, which is, if you go camping, a tent is a good example of a passive system. It just sits there, it's a tent. So would an old trapper's cabin or anything like that. Would just be a cabin and there's no active system in it. It's just the enclosure and you're inside of it and it does what it does passively with no input of energy whatsoever. The moment you put on a fire or you add an electric fan or anything like that, or a heat pump, as you were mentioning before, you're now adding an active system. And the sort of thinking is to try to make buildings as passive as possible, because that consumes no energy, and then to supplement them with active systems, but minimally as possible to supplement them. So if you have to add heat, ideally you would like to heat your house with a candle, right? You would like to cool it with a ceiling fan and not have to have air conditioning. Ideally, it would be designed that way, so that with very little energy input into the active systems, you would be getting the comfort and the shelter that you require. So that's the first point. So we should be privileging passive systems, and we should be really paying attention to minimizing active systems, and that includes heat pumps. So now where heat pumps come in handy is that they both heat and cool, which is great. So you have a single machine that does that. And they have great efficiencies, and they run on electricity, which means that you have a clean energy source potentially, especially if you're using renewable energy sources. You have a clean system that doesn't cause any carbon emissions, and therefore it's a good choice. Does heating, does cooling? Okay, it's great. The question is, how big is it? And if everybody has to have a giant size system, that means we have to have a giant electrical grid, and that means we're going to be pouring money into an electrical grid and maybe not into our health system, maybe not into long-term care, maybe not into education, maybe not funding arts and culture, but we'll be putting it into these big machines that make power. And that's not an evil thing, but I mean, there must be better ways to spend your money if you think about it.
All right. Good. I have a friend who moved to New Zealand and made some kind of walls, a new house with walls that are insulated. I mean, they are self-insulating,
Right.
Real thick. I don't know whether they're made of mud or something.
Yeah, there's a return to rammed earth. I mean, people discovered a lot of benefits of using rammed earth. It's an ancient technique, and you can make it very thick and very efficient. It's a very appropriate technology in many ways. Whether we could do that on mass scale to house the 100,000 people that come into Toronto or not is doubtful. But what we can learn is that these buildings are made with materials that are found as close as possible to site. So then when we talk about passive and active systems, we're talking about buildings in general. In the past, the sort of traditional mantra of the way we did buildings in North America was to basically design cheap, build cheap, and then operate and maintain expensive. So the other part of a building comes like buildings, in the same way that you have passive and active systems, buildings sort of have two sort of demands on the ecosystem. The first one comes when you extract materials to make the building. So there's a price to be paid environmentally for cutting down trees or extracting minerals or making concrete and steel and glass and so on. And then once the building is up and running, there's the energy that it consumes, and obviously even the water that it's going to consume because it's serving people, and the sewage that it's going to make. And of course, there will be even garbage and recycling and compost and all of these byproducts that are associated implicitly with buildings. So when you're looking at these two sides, nowadays people say, well, we would like to minimize our ecological footprint. So what are we going to do about the first part, which is the embodied energy and carbon in materials and the ecological footprint associated with those? So there's a great interest in going towards bio-based materials. So wood is the only renewable building material we have, along with a few other things like straw and so on. So you can do straw bale, and that's about it. I mean, you can use, and they do, believe it or not, sheep's wool has come back as an insulating material. So there's a whole bunch of stuff like that, and that all comes out biological, and it's a much cleaner, lower ecological footprint. So we can do that part of it. And then when it comes to the operating side, we want to, of course, reduce the demands for energy by making very robust passive systems. So once we get that part figured out, and the reality is we know how to do that. If someone was to come and say, well, do you need to invent anything new? as I tell my students all the time, no, we've got the toolbox is complete. There's no missing links. There's nothing that would stop us other than we just have to stop doing what we've been doing up until now, which we tend to do just because that's how humans work. Like, it's very difficult, and you know this as a sociologist, to get cultures to change the way they do things. It's not an easy thing.
I live in a high rise, and among a cluster of high rises, and I was watching next door. They were doing something that I was fascinated by, because their wall is white brick like mine, and they were attaching big sheets of something like an insulation last year, and they covered that whole building with some kind of big, I don't know, might have been plywood, but I imagine it wasn't. What do you think they were doing? And I heard somebody say, well, maybe we ought to do that to ours. I don't know. What is this? I mean, is it worthwhile for people to go gluing things on the outside of a brick building?
Well, the brick doesn't have very much thermal resistance value, so it doesn't keep you very warm. It's a good material for resilience in terms of against things like wind. So that'll take you right back to story of the Three Little Pigs, right? The brick building was the one the big bad wolf couldn't blow over. So that's good that way. But talking about heating and cooling loads, it would be good if you had some insulation. So what they do nowadays is they come and they add insulation to the outside of the brick, and then they usually put a stucco finish over top of that. And they refer to that as an overcladding. And in some cases, they'll even change the windows in the older high-rise buildings just because they were inefficient as well. And it makes a dramatic difference. You'll see energy reductions of 50 to 60, in some cases almost 70%. So there's great success stories involved in that. We built buildings very, very well at the time. So the people that own these buildings generally say, well, if it ain't broke, don't fix it. In other words, the building isn't starting to crumble or anything, but you can find out that just as soon as these buildings do start to suffer from deterioration, increasingly people are deciding to do overcladding and making the buildings more energy efficient. And it's a good thing. And we have a big building stock that has to be retrofit to bring down its carbon footprint and its operating energy. And it will. And the nice thing about it is, as crazy as it might sound to some people, this is really a good form of employment. In other words, if we want to make ourselves more sustainable, this is actually what we call the green economy. Mm-hmm. And you have to work on buildings right on site. It's not something that you can, well, I'm gonna send this work offshore to a call center in another country. No. The person has to stand on the scaffold right there on the building in your town, in your neighborhood, do the work, collect their paycheck, spend it in the neighborhood. Like, it's really good for the economy. You're making buildings greener, you're reducing greenhouse gas emissions, and you're providing meaningful, high-paying jobs. So it is a real win-win-win, and it's something that we should be doing more of. And I think we will. We're seeing encouraging trends. So that part's great.
There's a jackhammer going, or something equivalent, because it sounds like a machine gun. It's actually somebody on some part of this building replacing what do you call that? The pointing. They're taking out old grout and replacing it. And this has been going on for 6 months or so. But it occurs to me that it may be a wonderful job in terms of pay, but what a horrible experience it must be for the nervous system I can't stand it when it's on my end of the building. And I'm thinking, if I'm doing the work, it sure wouldn't be fun.
No, it's not. It's not. I think we have to find quieter ways of doing that. But these are all opportunities for technological innovation, So,
okay. Good point. Good point.
Yeah. It's like I remember one time talking to my dentist, and he said to me, what I would do if someone would invent, he said, a silent dentist drill. Because he said the noise is what scares people the most.
we should talk about mass timber now, because that's really why I wanted you to be on my show. I've talked to some other people earlier, a couple of an architect and a carpenter, the head of the Carpenters Union, and they were talking about how wonderful it is that now we can make pillars that are able to hold up high-rise buildings and stuff by gluing together pieces of wood, although that's not what they called it. But anyway, explain to me what mass timber is and whether or not it's really a good thing, because the more I thought about it, the more questions I had after our conversation.
Sure. Well, mass timber is really something that is a sort of modern reinterpretation of what we used to do in the past, when we used to do what they used to call mill building construction, which are many of them are in Toronto. There's many old buildings that were built starting at the end of the Victorian era, where they used heavy timber frames, and the outsides were done in brick, and they were called brick and beam buildings, for lack of a better term. And so all of the old, the old factories that have been converted into condos and so on, with all of the old beams exposed and so on, are examples of what was done. Now, back then it was different. We had huge trees in Canada, especially when they just finished putting the railroad across. And so importing like large Douglas fir timbers from BC all the way into places like Toronto and Montreal was easy, and there was a lot of it. But, it dwindled in supply, and people have issues about taking old growth forests and cutting them down to get big timber. So people learned how to make timber out of gluing together a whole bunch of small pieces, what we call engineered wood products, and they end up actually having better properties than the old timber. In other words, they're stronger because they are an engineered material. And so we have things like glue laminated timbers and cross laminated timbers and all kinds of materials today that didn't exist before. And they have permitted us to make very robust structural systems with the wood. It also means we don't have to kill old growth forests. We can take trees that grow quickly, because we're taking a bunch of small pieces of wood and gluing them together to make large scale pieces of wood. And that is great. So we don't end up having to hopefully we can leave whole parts of our forests intact as just natural ecosystems that go on their own. So the ecologists are saying it's important for us to do that, and the rest should be responsibly managed as sustainable forests that do get cycles of harvesting and then replanting and regrowth. It takes a long time. It's something that so usually when you see a forest get cut down, you'll only see it once. You won't see the second cutting because we don't live that long. But anyway. So there is a sustainable yield of timber, and we're nowhere near that in Canada. So we've never sustainably harvested what we could. So a lot of it just remains as forest, which is good for the lungs of the earth, if you will. And but we if we go that route, we're going to be using materials that are much lower in carbon and have a much lower ecological footprint, which is a good thing.
Hold on, wait, I don't get that. Much lower in carbon than cement.
Concrete or steel. Yeah. But the thing about wood is that it because it grows the way it does, it does not have this huge intense use of fossil fuels to make it. So if you're going to be making concrete and you have to fire up the clinker, to turn it into cement, you're generally using something like natural gas, and so you're burning a very hot flame to make the clinker, and that means that you're putting out a lot of carbon emissions for every bag of cement that you make. And so that doesn't happen with trees. They're extracting actually carbon dioxide out of the environment, mm-hmm. and that's what ends up going along with the water and so on in the photosynthetic process, ends up becoming part of the wood structure, and so it's sequestered within the wood. And that's a good thing.
But also that now there are really two kinds of concrete. I have interviewed a guy named, can't think of his name right now, but he was the head of an outfit called Blue Planet in California. And they are making what he says is carbon negative concrete. And he's actually making I think he's creating something like 80 plants in China to do this.
Right.
They rebuilt the San Francisco airport or put a new airport on or something that's all made from his concrete. So
Right.
I talked to him about it. I thought it was very impressive. But apparently it takes a long time for them to test everything and to make sure that it's going to be as good in the long term or something like that. What do you know about that kind of concrete? Anything?
Yes, we're making great advances in making more ecologically friendly materials, and that's sort of part of the success story behind mass timber. So when mass timber was being advocated by the forest industries as a better way to go ahead and build buildings, the other industries like the concrete industry and the steel industry realized that the science was accurate. It was, in fact, showing that the ecological footprint of building with wood was far less than building with concrete and steel. And they realized that there was an opportunity to reduce the ecological footprint of those materials. And that meant coming up with, technologies that did not result in such high emissions. And when he's talking about a carbon positive, he's talking about actually getting that carbon and sequestering it, capturing it and sequestering it within the concrete structure, so that it's not out in the atmosphere causing global warming. So these are so in many ways, I look at mass timber as being, for lack of a better term, sort of the to put it crudely, like sort of the shit disturber. It made people realize, hey, we're competing against this product that's made by Mother Nature that doesn't have any carbon footprint associated with it. We're going to really have to up our game if we want to make things. We never had to think that way before. Mm-hmm. So concrete sort of pushed things and got things going, and also got discussions going about, so what is the life cycle carbon production of a building, and what is the relationship between the energy that goes into a building, the embodied carbon and energy, versus its lifetime operating energy. And because of that, it's made everything better. So when people say, does this mean that like people who are advocates of mass timber buildings, which can be built as almost as tall as the concrete ones, not quite as tall, but they can go 25, 30 stories, no problem. And so we can build all kinds of buildings out of them. But the question is, should we? And I think, well, if we can have all of the materials reduce their environmental footprint, then we're free to choose these materials based on some of their properties that might be preferable. So typically you don't put wood in concrete with soil because it'll rot. So we will always need concrete for foundations, and it will be nice to have concrete that does not have a big environmental footprint. That would be great. Does that mean we could use wood up above? Yes, we could use wood, but we could also use steel if we're recycling steel and getting low carbon steel to be used, and so on. Well, steel is iron that has a little bit of carbon added to it. That's where the coke part comes in. That's why they used to make coke to go with the iron. So they melted down the iron and the coke. That little bit of carbon added to iron would make steel, and it would change its properties. So now they're trying to get that carbon. They're trying to get that out of sequestering carbon from the environment and capturing it in the process, and that's a good thing. They haven't stopped, by the way. Like, the research continues. I would say that probably in the next, let's say by 2050 at the latest, but probably by around 2035, 2040, I think most building materials as we know them today will have hardly any ecological footprint attached to them, because we will have pushed it that hard. And at that point, it will not make much of a difference which material you pick, because every building material will have done everything it can to become green. Now, they won't be exactly the same materials that we see today. So, for example, we will see materials that look like plastics, but they're not plastics, because actually they're made from organic substances. They could be made from the leftover husks of corn and stuff like that, because that's what people are starting to do. They're looking and they're going, can we make a biologically based, instead of using petroleum, can we be using something else to make something that would give us something like a plastic or a rubber, and they're discovering yes, we can. So they're starting to make engine parts for cars out of cellulose products, believe it or not. So and U of T, by the way, at the University of Toronto, there's a lot of work done in those material research areas. So it's promising. I would say we're doing a great job of it. I would say things like mass timber have pushed the agenda because mass timber was able to make certain performance claims about its environmental footprint, which were valid. They were evidence-based. It wasn't just advertising hype. And the other guys had to do something to up their game. And so in a way, it's been a real instigator. We've really pushed the agenda with mass timber.
Let me ask. I've got two questions. One, go back to this thing about steel, because I didn't quite follow how the steel coke. What's the situation with this coke? You're going to try. Is the game to try to get the carbon out of the atmosphere and put it in coke, which goes in the steel, or is
the coke was actually made out of coal, right? It was a byproduct of coal production.
Yeah.
So you would take something like coal and you would try to get the coal oil out of and the coal tar out of the coal, and then you would have leftover a coke material.
Oh.
And then you would take that coke and you would put it into those big, what look like huge vats where everything is being melted. And so you get all of this iron that's being melted, and you added the coke. So it's like making a cake batter, and then you end up with this molten steel, and then you start making steel out of it. Well, imagine not making coke. Imagine getting your carbon by getting it out of other processes, and that includes getting it out of the exhaust of. So if something has an exhaust, and that exhaust is emitting carbon, and having technologies that capture that carbon,
Mm-hmm.
okay, and believe it or not, they do it using things like algae and stuff like that, which is really interesting. So you have these creatures that actually like carbon dioxide and thrive and capture it, and then they're taking this form of carbon and they're putting it into the steel. Mm-hmm. So they're coming up with these really interesting techniques of sequestering carbon and putting it into the materials, which means that it does in a way become a net positive, because there's less carbon in the environment after you make the steel because you've taken it out, and it's locked into the steel. So and it's not free to be wandering around like a gas in the atmosphere, causing the warming.
The problem isn't the business of having to heat it so much that's causing the problem, but it's where you get your carbon to put in the steel.
Yeah, that's a big part of it. I mean, there's also the part that's associated with how we extract the iron ore. So it's, the material extraction and processing of materials mm-hmm. can also give the material a high carbon content. So if I have to use a lot of fossil fuels to extract material, then I'm causing a problem. So I have to come up with what we call clean techniques for extraction. So if I'm using either electric powered or, let's say, hydrogen fuel powered equipment to do my extraction and manufacturing, then I'm not exerting a carbon footprint. So I've lowered the carbon content of that material. Mm-hmm. So when you do this whole business of life cycle analysis, which is really part of mass timber, in the sense that the reason people are excited about mass timber is those of us who study the life cycle of buildings from cradle to grave, so to speak, and look at what their environmental impacts are. We have to understand that a large part of the environmental impact comes in the extraction of the materials themselves. Mm-hmm. And so we were using very inefficient ways of doing that, and we were generating a lot of carbon emissions with the machinery and equipment that goes to extract these things. So we're having to think about it at each stage of its evolution. And everybody now is starting to think of, and we're sort of starting to row together for a change to say, okay, if we're going to row in one direction, what are we going to do? Well, we're going to drop reduce the ecological footprint of everything we possibly can. And that's a good thing. And it's going to take about a generation, which I guess in the old days, a generation was 20 years. I don't know what it is today. People are having kids much later. So is the generation 25 or 30 years? Probably it is now. I don't know. Depends what part of the world you come from. but it's going to take one generation for us to go through this conversion, and I'm confident that we're going to achieve that. And there will be areas that will lag a bit, but I'm an optimist. And I'm an optimist because we have the answers. If we were still scratching our heads trying to figure out what it is we have to do, I think we would be in trouble. But I think we know what we have to do. Part of it too, of course, is just coming up with the instruments like carbon taxes and so on to give people incentives to go towards the cleaner sources of energy and production. Because if you're not having to pay any money, if you can pollute the environment at no cost, of course that becomes the low cost solution that you're going to go to in a capitalist system. But the moment you're being charged what it actually costs to pollute, and if you're someone who, like this year in British Columbia, endured forest fires and flooding, and if those were caused by climate change, then those are the costs that should be borne by somebody who's causing that climate change. And once we make that connection, people will change their behavior. They'll say, well, I don't want to be taxed on this. I would rather do something to avoid that. And so mass timber is part of the movement towards changing the way we viewed buildings, because in order to sell the mass timber concept, things like life cycle costing and passive and active systems and the difference between embodied energy and operating energy and emissions, all of these connections had to be made. And the moment they were made, people were starting to apply them to the other building types and the other building materials. And all of a sudden we were having what I like to call an adult conversation. We're having an adult conversation as a society about what kind of buildings do you want to build.
Right? Okay, that's really wonderful. Now, I've been in my own little thinking about how do I appraise these things? And I talked to a lot of forestry people, and honestly, forestry is, I think they're confused because I try to get answers to simple questions like, where should we grow trees? And is a boreal forest, even a simple question like, is a boreal forest a sink or a source of carbon now? And the answer is, well, we're not sure. Or sometimes it is, sometimes it isn't, or it depends on what part of it you're talking about or what trees you're talking about. In other words, it gets really unanswerable. But the other kinds of questions that were arising in my mind when I started thinking whether I want to believe in this mass timber thing or not was, well, what about different? I mean, you're going to cut down trees, but which trees should you cut down? The big ones or the little ones? The big ones do not have the same, I guess you could almost call it metabolism rate, because they don't sequester carbon as fast or as much per pound of wood or whatever as the younger ones. But on the other hand, they contain a lot more. And even if they're just, I would figure if they're just sequestering, say, 1% per year, as compared with maybe 10% per year for small trees. These are just things I've made up. It doesn't correspond to any real thing. But it might be that because they're big, they're actually sequestering more because they're big. And even 1% of something big is more than 10% of something small, that kind of thing. So I don't know. I don't know which trees they should cut down. I don't know whether they should cut down any trees. Then I've been told, well, there are times when you have to go in and clear trees anyway because they've died. You may as well take out the old trees that have died and at least use that wood, which makes sense to me. If you can economically go into a forest and remove only some of the trees and leave the other ones that are healthy and young or old, depending on which you want to value higher. You see the kinds of quandary I get into when I lie awake.
Absolutely. No, this has been an ongoing discussion in the building community as well, just because people want to build with wood. I mean, let's face it, Canadians build their houses out of wood. We use lumber and we build houses. And that's going to go on. And so the question always becomes, well, what should we be doing? The reason the thinking seems confused, I don't think it's really confused. I think what it is that what we're discovering is that some of our forest practices that we think are sustainable, the evidence is starting to show that maybe they're not so sustainable after all. So for example, we used to think that clear cutting was something that mimicked what would happen if there was a forest fire, because forest fires, what they refer to as disturbances, have been going on since the beginning of time, and there was nobody to go and fight the fires. They just burned, and some of them were huge, like some of the historical fires. When they're finding, they're doing carbon dating of the burnt stumps of trees, they realize that, oh my God, this fire, took out an area that was, in North America, an area that would be, bigger than the size of Ontario, but it happened, 8,000 years ago or something, and no one was around to record it, so it just happened, but then it grew back. It's like everything else; it took time, and so then they're saying like, well, when we go in and clear cut, that's like having a forest fire. But then people are coming back and saying, no, it's not exactly the same. And so then the question goes, well, what do you mean? They say, well, because you're disturbing a lot of stuff with the equipment rolling over the turf, whereas when a forest fire moves through, it burns the stuff that's above the ground, but all the stuff that's in the ground seems to remain. And within a year or two, it springs back up, and it comes back a lot faster than if you drive over it with all your skidders and wood harvesting equipment and so on. So as we start to do more research, we're discovering, so what are the better ways? Should we be doing selective harvesting, leaving certain big trees? We're also discovering that there's a difference between a stand of trees. So if I go and, let's say I have a piece of fallow pasture land that I don't want to use anymore as a farmer, and I go and I plant trees in a row, which is something that they do very commonly in Europe. And I start a tree plantation, basically. And, 50 years later, I've got this stand of very large trees. They're sort of all in a row. That doesn't matter. I could have planted them randomly, but however I did, I've got this stand of trees, and I might turn around and say, well, here I've got a forest. And what they're discovering is that's not a forest. It's a tree plantation. A forest has got a whole bunch of dimensions to it that deal with everything from the type of fungus that's growing between the trees, the types of different creatures that inhabit the earth, the different insects that actually live in the soil, and the types of exchanges that are occurring. And then there's all of the wildlife that inhabits the trees, whether it's owls and woodpeckers. And so they say when you're looking at it as an ecosystem, it's a really, really, really rich thing, and it has a whole bunch of complexity to it. And really the plantation, while it might have the same number of trees, it doesn't have the biodiversity. And so biodiversity is sort of an important thing. So in the readings that I've been doing, because I've been trying to sort this out as well, I think a lot of people are, we're trying to figure out, well, what is the right thing to do, obviously, and how do we do it in a sustainable fashion? And I think we're getting closer to that answer. But right now, how can I say it? I like to say that we're at the stage, I don't know if you remember reading about this when you were a student, because it's not my subject area, but I remember there was a time when they were developing, I guess you would call it religious studies, where scholars were talking about stuff like how many angels on the head of a pin.
Yeah.
And I think we're at that stage in forest ecology where we're really drilling down really deep, and we're asking these sorts of questions. And sometimes I think the answer lies more in something like the way the indigenous people approach forests, where they actually believe that trees are a type of person, and that has a consciousness, and then there's people that are discovering that in fact trees do have not the way we know it as a human consciousness, but they have a type of consciousness, and they're aware of changes in soil conditions and stuff like that. Anyway,
I love the stories about how they take care of each other.
Yes.
They one of them gets short of some kind of nutrient, and the other will pass it over.
Yes, no, but this the work that was done by Suzanne Simard, I believe, from UBC. This is groundbreaking research that's showing that what the nature of this complexity is. People were all raring to go. They wanted to see what they called the mass timber revolution. They wanted to see All our buildings get built out of mass timber. They wanted to see more of the forests harvested and turned into mass timber products and all this kind of stuff. And I've actually been really happy that that hasn't happened. That in fact we've hit a stall where people aren't sure what to do, so they're sort of backing off on the mass timber and they're trying to do other things. And I'm sort of thinking that's a good thing, because if we still don't know what the right thing to do is with the forests, it would be terrible to all of a sudden go in there and start heavily exploiting them, only to discover that we're doing the wrong thing. And I'd rather wait a while and do the right thing. But in the meantime, mass timber has brought about a discussion about the life cycle of buildings and the ecological footprint of building materials that has been a very healthy exercise. So in one way, it's done its job. It's to me a very exciting way of now looking at buildings, and I don't think we'll ever look at buildings the same way anymore. I think we will look at them from a life cycle perspective. I think we will see them in all of their dimensions, and I'm happy for that. And I hope we get it right. I'd like to see Canada get it right and do things differently. If you go to places like Austria, which is like the sort of mass timber capital of the world, in terms of like they have the most robust industry. They sort of invented mass timber and got into it in a big way because parts of Austria were very wood based in their buildings as well. And and they're importing. Well, I don't know if they're going to be doing it anymore, but they were importing a lot of their wood from Russia and stuff like that. So they were getting their wood and they were cranking the stuff out, and they weren't questioning where it was coming from, whether it was sustainable or not. They were just going for it. And so we sort of are lucky. We don't have to compromise the quality of our forests as soon as they did. I don't think they have any what we would call forests anymore. I don't think there's only a few places in Europe. I think there's a part of Poland and there's a few other small places where they have what we would call intact forests, where they really are the way they always were, and the humans haven't disrupted them. Very few areas. Basically, everything in Europe has been cut down, regrown, and so on. It's not nowhere near what it used to be. We still have quite a bit of intact.
They're putting a wall or something in that forest in Poland to keep out those Syrian immigrants that Lukashenko was sending in, and it's really going to ruin. It's going to split the biome.
Yeah, I know. It's so what I'm getting at is that I'd like to see us get it right, and I think we can in Canada. I think we can show the world how to do it right.
Tell me where they make this stuff now, if they are doing it. Where does? Are there factories here in Ontario that take small pieces of wood and glue them together? And what kind of stuff do they use? And do they do it to specifications? Do you send them say, I want to have a beam that's this dimensions, and please make one for me?
Absolutely. It's a very mature industry. Mass timber products are now manufactured in Quebec, Ontario, Alberta, and British Columbia. So those are the four provinces that have active plants that produce things like glue laminated beams. They also produce slabs that are made from cross-laminated timber or from dowel laminated timber. So these products are made, and yes, you do specify what it is that you want. These are engineered products, and they manufacture them to specification. It takes a while. The advantage, of course, is that when the time comes to put them together, they go together sort of like an IKEA piece of furniture, because everything is done. The level of craft is higher because they're using computer numerically controlled equipment to do all of the drilling of holes and all of the type of shaping of the wood. So it's very, very precise compared to what, let's say, a human would do. Although humans are capable of it, but the man hours would be huge in terms of fabricating things to that level of precision by hand. So because they're using robots basically to do the milling and so on, they're getting tremendous precision, and it works out really well. And we still continue to do a certain amount of mass timber buildings. It's just that it's a background industry. If you were to compare it to concrete and steel, well, it probably accounts for less than 1% of the concrete
Okay.
and steel buildings.
Okay, now say, have you actually been somebody designing a building where you decide what kind of beams or pillars you want them to make, and you make a contract and actually have it done for you?
Right.
Do you?
Well, I mean, that's every manufacturer works with whatever material they have available to them, and we mostly use what we would call the spruce pine fir family of trees that are. We're basically using trees that come from the boreal forest, whether you're doing it in Quebec or Ontario or Alberta or British Columbia. You're using basically things that are sort of boreal forest based types of trees, although in some jurisdictions it's different. Like Australia has quite a mature mass timber industry, but they have trees just like they have those weird animals that you don't have anywhere else in the world. They got these weird trees that we don't have anywhere else, but that's what they use. And so we're using locally, like I guess we call them Canadian tree species, and that's what you get to choose from. It's not like you can say to the person, well, make me a glue laminated beam, but I want it made out of cherry wood. Like I don't think anyone would do that for you. They might, but I doubt it. They would say, this is what we have available, but you can, the size and the shape you can determine. So generally that's a decision made between the architect and the owner. So a person comes and says, oh, I want to build an arena, and they go, well, you could build it out of steel or concrete, or you could build it out of wood. And I mean, there's a lot of beautiful arenas that have vaulted wood ceilings that are done in glue laminated beams that are in the shape of an arch, for example, and with wood roof decks and so on. And if the owner goes, yeah, I think I like that aesthetic, I'd like to go with wood, then that decision's made. The structural engineers then, based on the layout and the look, will determine what the size of those members has to be. They'll specify all that, and then it gets manufactured and shipped to site and assembled. So that's the process. It's a very mature industry that way, but its sales are low compared to all the other building types that are done. So
I think there's one being built in Toronto down at the university someplace, isn't there? A mass
yes,
timber building?
we're going to have an academic tower built at the University of Toronto on the St. George campus. There's another one that's being built. It's going to be built for George Brown down at their waterfront campus, and there's one that's going up that's going to be for the Toronto Regional Conservation Authority. Their new headquarters, New York University, will be a mass timber building. So they are going up slowly. Okay. It's nowhere near the revolution people wanted to see. But as I said, I'm very glad that we're not rushing into this. Mm-hmm. I think, like everything else, you're always wise. They always say, don't dive headfirst into uncharted waters. So I'm the type of person, I like to stick a toe in the water. I want to know what the temperature is before I leap in, just so I can brace myself for the shock if it's cold. And I think it's good that we're getting into this slowly but carefully and surely, right? I don't think it's a wise thing ever to just go whole hog into something, and then when you're in the middle of it, like one person said, it's like, when you're up to your ass in alligators, it's hard to remember that your original intention was to drain the swamp. So you really have to watch.
Okay. Well, I'm delighted that you have this more cautious approach. Makes me feel much better, because I was worrying that somebody out there is doing something without thinking it through, and I wanted to hear how they were thinking about it. So I feel much better today that you've enlightened me a lot. Thank you very much. It's been fascinating. Very good conversation. Enjoyed it. So we're through now. See you. Bye.
All right. Take care, and thanks for having me.
I loved it. Project Save the World produces one of these shows 3 days a week, and sometimes more. This is episode 425. You can watch these or listen to them as audio podcasts on our website, tosavetheworld.ca. Eventually, we even post the transcripts there. When you get there, look around, because we have conversations going on there all the time about 6 global issues, plus potential reforms in governance, economics, and civil society. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. After you've watched or listened, scroll down and share your own thoughts about the show with the other viewers. This is a place for dialogue, so please join in it.